Hello and welcome to my science tutorials. In today's video, we want to look at the addition of like fractions. So without further delay, let's begin. So let's start by looking at what a fraction is. When we say fraction, what do we mean? So fraction simply means part of an amount. A part of an amount. So for example, let's say I have a pizza. So this is a pizza and I don't want to finish eating my pizza in one go, so I decided to divide the pizza into four equal parts. Okay, so we are assuming this is a perfect round pizza. Okay, uh, so this is my pizza and I decided to divide it into four. Now if I consume one part of the pizza, so the shaded part is the part that I have consumed, and I've been asked what is the fraction of the pizza I have consumed. First of all, the first thing I need to do is that a fraction can be written as a number over another number. So a typical example may be 2 over 3, 6 over 7, 9 over 3, anything. So this is a fraction. Now the number at the top, or the numbers at the top, are what we call the numerators or the numerator. The number at the bottom is what we call the denominator. The denominator. Now the denominator is the total number of parts that a particular item or an object has been divided into. Now if you take this pizza for instance, I have divided it into 1, 2, 3, 4 equal parts. So it means if I want to write the fraction of this, my fraction is equal to be, the denominator here by default is going to be 4. Now if the question asks what is the fraction of the consumed part, so fraction of the consumed part or fraction of the amount consumed, it means that if you look at this 1, 2, 3, 4, I have consumed just 1 out of the 4. So the fraction of the consumed part is 1 over 4. Now if the question asks me what is the fraction of the remaining amount of the pizza, the remaining amount is the part that I have not consumed or I am yet to consume. So if we go back to our pizza, we have 1, 2, 3. 3 parts or 3 slices is yet to be consumed. So we know that our total pizza is 4, that is the number of sizes or parts it has been divided to, but the part that is yet to be consumed, let me use another color for that. So these parts that are yet to be consumed are 3, so it's 3 out of 4. So 3 over 4 is the part of the pizza that I am yet to consume, and 1 over 4 is the part that I have consumed and not consumed. So this is what fraction basically means. So consumed and not consumed, and if we look at this, it's a perfect example for that. Now fractions can be divided based on whether we want to add, subtract, multiply or divide. We can say fractions can be divided into two major categories. We say 1, like fractions, and 2, unlike fractions. Unlike fractions. So when we talk about like fractions, we are talking about fractions that have the same denominator. So for example, let's say I have 7 over 9 and another fraction, let's say 3 over 9. Now because their denominators are both 9, so you can see over here is 9, over here is 9, these two fractions can be said to be like fractions because they have the same denominator. On the other hand, unlike fractions means fractions that do not have the same denominator. Now note, we are using the denominator on the basis to select whether a fraction is like or unlike. So if we have two fractions and then they have the same denominator, we are saying they are like fractions. And then if we have two or more fractions and then they have different denominators, we are saying they are unlike fractions. So a typical example can be, let's say, 3 over 5, 2 over 7, and maybe 1 over 4, right? If you consider all these three fractions, their denominators are different. So this is 5, this is 7, this is 4. So none of these fractions are like, they are all unlike fractions. Now let's continue to look at the purpose of this video tutorial, which is to look at the addition of like fractions. So when we have like fractions, how do we add them? So let's proceed to look at that. So let's look at an example, a very simple example. So we have 2 over 6 plus 3 over 6. So this is our example. Example number 1 is 2 over 6 plus 3 over 6. Now if you look at these two fractions, you realize that both fractions have 6 as their denominator. So because they have the same denominator, we are saying they are what? They are like fractions. They are like fractions. So let's keep note of that. Now, what do we do when we have like fractions? How do we add them? Now, for like fractions, because their denominator is the same, all we do is we write our division sign here. Then we bring one of the denominators. Because they are both 6's, we bring 1. So we bring 6 over here. Now, all we have to do is to add the top numbers. So which is now 2 plus 3. So our answer over here is now 5 over 6 as the solution for this problem. Let's look at another example. Example number 2 or B. So we have 1 over 4 plus 2 over 4. So the first thing we do is to look at this fraction. Do we have the same denominators? Yes, we have 4 and 4. So which means these two fractions are like fractions. So when we have like fractions, all we do is to maintain one of the denominators. So we have 4 over here, and then we add the top numbers, the numerators. So it's now 1 plus 2. So this is equal to 3 over 4 as our answer over here. So let's look at more examples. So this is A, this is B, this is C. So C, we have 1 over 8 plus 6 over 8 plus 1 over 8 again. Now, whether we have 3 fractions, 4 fractions, 5 fractions, or even more, the moment they all have the same denominators, we maintain the denominator, one of them, and then we add the top ones. So let's look at this. The solution to this problem is the denominators over here are all 8, 8, 8. So we maintain one of them. Then we add the exponents. So we have, and then we add the numerators. So we have 1 plus 6 plus 1. So 1 plus 6 is 7 plus 1 is 8. So this is equal to 8 over 8. And 8 divided by 8 is equal to 1. So this is our answer. Right, let's look at another example. 5 over 10 plus 2 over 10. So without going through this process, you can simply just mention your answer. So your answer straightforward. The denominators are here 10, 10. So it is 10 over here. 5 plus 2 is 7. So your answer is 7 over 10. So this is how we add fractions. So let's have a look at more examples. So let's say I. We are to find the sum of the following fractions. So we have 4 over 11 plus 6 over 11. And then I. We have 3 on 13 plus 8 on 13. Then we have I. We have 12 on 40 plus 11 on 40. Right, so let's go ahead and look at the solution to these problems. So the first example we have is 4 on 11 plus 6 on 11. As usual, if we look at this fraction, we can establish that these fractions, the two of them, are like fractions because their denominators are the same, that is 11 and 11. So we maintain one of the denominators and we just add the numerator. So it is now 4 plus 6, and this will give us 10 over 11 as our answer. Alright, let's look at the second one. We have 3 on 13 plus 8 on 13. This is equal to, these are also like fractions, so we maintain one of the denominators, which is 13, then we add the numerator. So we have 3 plus 8, and 3 plus 8 will give us 11. So we have 11 on 13 as our final answer. So let's look at I. We have 12 on 40 plus 11 on 40. The same way, we just maintain our denominator because it's the same, 40, 40, and then we add the numerators, which is 11 plus 12, or 12 plus 11. So this is equal to 23 on 40 as our final answer. So thank you so much for watching. This is how we add like fractions in mathematics. So thank you once again for watching, and I will see you in the next video. Bye bye.